Welcome. All right, so the next part about this, we were just talking about that protein synthesis and transcription, then translation. And I mentioned that I wanted to talk a little bit about tRNA. And I also want to mention the idea of what I think of as the secret decoder ring. The codon chart. Talk about that, how you use it. Okay, so I mentioned tRNA. So it kind of has this structure like this. All right, and on the bottom are 3 letters called an anti-codon. And an anti-codon is going to use this again. It's RNA, so we're going to have A's and T's and U's. But like for instance, if we had the start codon down here and was AUG, you remember, we would have UAC because they're a complementary base pairing. And of course, this, which we'll see in a second, is going to bring over a specific amino acid called methionine. Methionine, or MET for short. And I know that because that's on the secret decoder ring. More about that in a second. But there's a special enzyme. Its whole job is to make sure that the shape of this UAC matches up with the shape of this amino acid, methionine. And it does that for all the different amino acids. Now, how many different amino acids are there? So, mention there are 20 amino acids. And so, if you had to come up with something with 20, and all you had was 4 choices, you had either A, U, C, or G. And if you had to code for 20 different ones, how many? Well, if I just use one letter, if my codon was only 1 letter long, how many choices could I have? I could have 1, 2, 3, 4. I could have 4 choices. Well, if I had 2 letters long, how many choices could I have? Well, for the first letter, I could have 1, 2, 3, 4. And for the second one, I could have 1, 2, 3, 4. So 4 times 4 is 16. It's still not quite to 20. Certainly not enough with 1. So what do I need to do? If I have 3 letters, 4, 4, 4, each spot can have 4 different choices. I get 64 different choices. But you say, we don't need that many. We only need 20. Well, you're right. But if we only did 2 letters, it was 16. We wouldn't have enough. So we call this, you should know that these codons are redundant. Okay? Means that you're going to have a couple of different codons that code for the same amino acid. Not the case with methionine, but there are some others, like proline, leucine, for instance. They have multiple different amino acids. All right, so I'm going to put a little magical ripple on here, and we're going to go right to the codon chart. Okay, so here we go with our checking this out here. So first we're going to look at the first letter on this left side, the second base along the top, and let's just say that the first base is A. So it's going to be somewhere in this big block right here. And now the second letter will be U, and it's in this big column right over here. So somewhere in this box right here is where our code is going to end up. Let's say the third letter is G, and so we get AUG, which, oh, by the way, goes for methionine and is the start codon. So let's look up UAU. So here's first letter U, second letter A, somewhere in this box, and third letter U right there, it codes for tyrosine. Okay, what about UAA? So there's U, here's A, and there's A, and G. Notice that both of these produce what's called a stop codon. And so stop codon, again, is going to be the thing that's going to turn off the production of the protein. It's just going to end the protein. So there's another one, UGA as well. Okay, so now what I want you to do is try looking up GAC. Hopefully you found GAC was right over here. Asparagine. Oh, and here's our next chart. So this one shows first letter in the middle, second letter, and the next one, and the third letter on the outside with our amino acids on the very, very outside. So we kind of work from the inside out. So A, U, G, still in this method codes for methionine, which is also the start codon, even though that's not shown. And what about UAU, like we did before? So here's U, here's A, and here is U. And again, it codes for tyrosine, just like before. So it works the same way. What about UAA? There's that stop codon, as well as UAG, and then there's UGA as well. Okay, so now give that GAC a try again. So again, find the G, start in the middle, then go to A, the next line, and then the outside circle, go to C. And you can see the amino acid is aspartic acid. Okay, hopefully that helps.